Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Welcome to today's explainer, Demystifying Virtualization, Solving the Hardware Headache. Today we're absolutely going to unpack the invisible engine that powers modern cloud infrastructure. We're looking at exactly how companies manage to serve literally millions of users without needing a separate physical computer for every single one of them. It's a real game changer, so let's dive right in.
So how do you actually service endless client requests with limited hardware? To really understand the massive shift virtualization brought to computing, we've got to understand the headache it was built to solve. So I want you to put yourself in the shoes of an IT manager for just a second. Imagine you've got a finite, strictly limited amount of physical hardware just sitting there in your server racks. But your business is booming, it's growing fast, and you're staring down this seemingly endless queue of clients. The fundamental question hits you. How on earth do you service all of these endless requests with just that limited pool of hardware? Honestly, it feels like a totally impossible allocation problem.
And let's be real, clients are notoriously demanding and unpredictable. You can't just set up one standard run-of-the-mill machine, dust off your hands and say, okay, we're done here. Nope. You are going to face an absolute barrage of conflicting needs. Clients will request entirely different operating systems from one another. They'll need vastly different storage sizes depending on their data, and just to make things fun, they might completely change their request right when you think you've finally got it all figured out. The sheer chaos of trying to keep up with these constantly shifting targets using just physical metal and wires, it is absolutely staggering.
Just picture the daily reality for a second. Customer A comes to you, absolutely demanding Windows 7 for their legacy software. Meanwhile, Customer B is completely adamant that they need Linux for their development environment. And guess what? You have to accommodate both of them. You've got to give them exactly what they want to keep the business running smoothly. But doing that creates a massive, and I mean massive, logistical and physical headache if you're relying purely on physical hardware.
This whole chaotic situation, it quickly turns into a strict math problem. Let's say you've invested heavily in a rack of high-end octa-core machines. These things are absolute powerhouses, right? But, and here's the catch, your incoming clients each only need a basic dual-core machine to run their specific tasks. Well, actually, think about it. If you hand over an entire octa-core machine to a user who only needs 2 cores, you are leaving an enormous chunk of expensive computing power just sitting there, completely idle. It's literally like buying a giant mansion just to live in one single room.
Now, the old traditional strategy to handle this mismatch was pretty straightforward, but man, was it flawed. The idea was to just allocate a brand new physical machine for every single incomer. Customer A gets a physical box. Customer B gets a physical box. Everybody gets a box. But that brute force strategy of one physical box per customer, yeah, it's a total dead end. It's completely broken and unsustainable. You'll literally run out of physical space in your server room, blow straight through your entire budget buying new machines, and still leave massive amounts of computing power completely unused.
So it becomes painfully obvious pretty fast that wasting high-end machines or just buying endless physical boxes simply isn't going to cut it. We desperately need a more powerful technique to deal with this dilemma. And boom, this is exactly where virtualization steps in to save the day. It's this incredibly clever paradigm shift that basically allows us to break the physical limits of our hardware and completely rethink how we allocate computing resources. To really grasp how it does this, let's step away from the server room for just a quick second for a conceptual refresher. Broadly speaking, virtualization is simply creating a virtual rather than an actual version of something. Think about, say, visiting Washington, D.C. The actual version requires you to pack a bag, physically travel there, and stand in a long line for a tour of the White House. But the virtual version? That's like taking an interactive web tour. You get the full experience, all the functionality, but without the physical footprint of actually being there in person.
Bringing that analogy straight back to computing, you've probably actually done some virtualization yourself without even realizing it. Seriously, if you've ever taken a single physical hard drive and partitioned it so your computer sees a C drive and a D drive, well, you've engaged in virtualization. You basically used software to trick the hardware into creating more than one virtual drive. Your operating system treats them like completely separate physical disks, even though they live on the exact same piece of metal. It's kind of like magic, right?
Which brings us right to the core technical definition here. Virtualization is a technology that allows multiple operating systems and applications to run on a single physical server.
Remember that octa-core machine we talked about earlier? And customer A who desperately wants Windows, and customer B who insists on Linux? Well, by injecting a virtualization layer into that single octa-core machine, you can now run Windows and Linux simultaneously on the exact same box. Just like that, one server is doing the work of many.
So what actually drives a company to make this big shift? Well, there are a few major reasons. First off, it instantly cures that problem of underutilized hardware. No more wasting an awesome octa-core machine on a tiny dual-core task. You just allocate exactly the virtual resources that are needed and nothing more. Second, energy efficiency. Think about it. Running one physical machine with 10 virtual servers consumes vastly less electricity than running 10 completely separate physical machines. And third, IT operations cost. Less physical hardware simply means less money spent on purchasing, less physical space required, and significantly lower cooling bills. It's a win-win-win.
But wait, the operational payoffs go well beyond just that initial setup and really turn into a massive win for IT teams across the board. As we just noted, energy conservation makes virtualization fundamentally green, which is huge. But look at the day-to-day ease of management. It significantly reduces backup and recovery times because, well, you're dealing with easily movable virtual files rather than clunky physical hard drives. It also provides this perfect, risk-free sandbox environment for testing software configurations. And crucially, this is absolutely huge. It offers robust isolation and security. Even though multiple clients are chilling on the exact same server, their environments are strictly isolated. So if customer A's virtual machine suddenly crashes, no worries at all. Customer B's virtual machine just keeps on running perfectly without a single hiccup.
So we've seen the absolute chaos of client demands and the sheer waste of traditional servers, right? And we've seen it all solved by making just one machine act like 20. It is a fundamental, massive shift in efficiency. So I want to leave you with this thought. Take a real hard look at the servers running your own operations right now. Are they truly working at their full potential? Or are you still relying on a totally outdated strategy from the past? Maybe it's time to get virtual. Thanks so much for joining me on this explainer. I'll see you next time.